Hello, the purpose of this video is to introduce you to three famous fractions of right triangle trigonometry. These famous fractions are usually called trigonometric ratios or trig ratios, and the first one is called the sine ratio. The sine ratio, that's just the name for a fraction that is so famous that it deserved a special name. To create the sine ratio, you write the length of the opposite side of a right triangle over the length of the hypotenuse of a right triangle. The second trig ratio is the cosine ratio. And again, this is just a fraction that is so famous in math that it has a special name. To write the cosine ratio, we write the length of the adjacent side of a right triangle over the length of its hypotenuse. And finally, the last trig ratio is the tangent ratio. And to write the tangent ratio, we write the length of the opposite side over the length of the adjacent side. It is very important that you memorize these three ratios. The sine ratio is opposite over hypotenuse, the cosine ratio is adjacent over hypotenuse, and the tangent ratio is the opposite over the adjacent. Many students remember these ratios by remembering so, ka, toa. So, ka, toa. The so part comes from sine being opposite over hypotenuse. The ka part comes from cosine being the adjacent over the hypotenuse, and the toa part comes from tangent being the opposite over the adjacent. So if you can remember so, ka, toa, you can usually get all of the parts that you need in the right places when you're writing one of these ratios. The purpose of today's lesson is not to find the length of a side of a triangle, and it's not to find the measure of an angle of a triangle. That will come later. Today we're just practicing writing the ratios, so we won't find any information that we don't already know about when we look at the triangle. So in this problem, they want us to find the tangent of y. So we'll be using the tangent ratio, and our reference angle is angle y. So we highlight the two sides of the triangle that make up the reference angle, angle y. We label the longer of those two sides as the hypotenuse and the shorter of those two sides as the adjacent. And then the remaining side that's not highlighted is called the opposite side. So if we want to find the tangent ratio, then what we need to do is just write a fraction that has the length of the opposite side on the top and the length of the adjacent side on the bottom. So the answer to this question will look like this. The tangent of y is the opposite over the adjacent, so that's 28 over 45. And that's the answer to this problem. On this problem, they want us to find the sine of w. So since we're finding the sine of w, we'll use a different ratio, and w is now our reference angle. So we highlight the two sides of angle w. The longer of those two sides is the hypotenuse. The shorter of those two sides is the adjacent. And then the other side or remaining side is always called the opposite. So in order for us to finish this problem, we just need to write the sine ratio. And the sine ratio is the opposite over the hypotenuse. So our opposite is 45 and our hypotenuse is 53. So our answer is the fraction 45 over 53. This is a problem right off of your digital assignment. To start with, they want us to find the sine of d and the cosine of d. The sine of d and the cosine of d. So the sine of D will be the opposite over the hypotenuse, and the cosine of D will be the adjacent over the hypotenuse. So now, if we highlight D, which on this problem is our reference angle, and we look at the two sides that make up angle D, the longer of the two will be the hypotenuse, the other will be the adjacent, and in this case, 12 is the opposite. So if we want to write the sine of D, we just need to take our opposite and write it over our hypotenuse, which is 12 over 15. If we want to find the cosine of D, we take our adjacent, which is 9, over our hypotenuse, which is 15, and those are our two ratios, or famous fractions. And like any fractions, if they can be reduced, we need to reduce them. So I can divide the top and bottom by 3, and that will give me 4/5. And I can divide the top and bottom by 3, and that will give me 3/5. So now when I go to fill in the answer, the sine of D is the fraction 4/5, and the cosine of D is the fraction 3/5. To answer the remaining parts of this problem, finding the sine of E and the cosine of E, we're going to need to erase our work on the triangle, because now instead of having D as our reference angle, we will have E as our reference angle. So E is our reference angle. Those two sides make up angle E. The longer of the two is the hypotenuse, the shorter of the two is the adjacent, and the 9 is the opposite. Now we're going to try to find the sine of E and the cosine of E. The sine will be the opposite over the hypotenuse. The cosine will be the adjacent over the hypotenuse. So for this problem, the opposite is 9 and the hypotenuse is 15. And the adjacent is 12 and the hypotenuse is 15. And we already found that if we divide those by 3, we'll get 3/5 and 4/5. So when we go to fill in our answer on the digital assignment for the sine of E, we'll fill in the fraction 3/5. And when we fill in our answer for the cosine of E, we'll fill in the fraction 4/5. On this problem, they want us to find the tangents of the acute angles. Well, there's one right angle in this triangle and two acute angles, angle J and angle K. So for the first part of the problem, we'll use angle J as our reference angle, and we'll start out. Here's angle J. Those are the two sides that make up angle J. The longer is the hypotenuse, the shorter is the adjacent, and the remaining side is the opposite. So if we want to find the tangent of J, we're going to write the opposite over the adjacent. So on this problem, our opposite is 5 and our adjacent is 3. And that fraction can't be reduced. So for the tangent of J, our answer is 5/3. Now they're changing the reference angle on us when they ask us to find the tangent of K. So now I'm going to have to do some erasing, and to find the tangent of K, now K is my reference angle. I highlight the two sides of the reference angle. The longer of the two is the hypotenuse, the shorter of the two is the adjacent, and the remaining side is the opposite. So now if I want to find the tangent of K, I'm going to write the opposite over the adjacent. But because the reference angle has changed, the location of the opposite and adjacent have also changed. So now my opposite side is 3 and my adjacent side is 5. So when I go to fill in the answer for the tangent of K, the answer will be the fraction 3/5.